Hello, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Mahamad Aiman Syauqi, and now I will be presenting about assignment for MTK 3032, which is Statistic for Chemistry. Let's go to the introduction. This is 32 data sample that was chosen randomly from data bank using Microsoft Excel. Now, let's go to question 1. Question 1. Find the 90% confidence interval for the average serum cholesterol data. The population standard deviation is 22. So let's look at the data. X bar for this data is 216.969. The standard deviation is given, which is 22. The number of this data is 32. So the alpha is 1 minus 0.90 equal to 0.10. So the z-score is plus minus 1.65. So let's find the confidence interval. The formula is x bar plus minus z time standard deviation over square root of n. So when we put all the data in, so we'll get the answer is 223.386 and 210.552. So let's go to question number 2. For question number 2, find the 95% confidence intervals of the proportion of education level is graduate degree. So we use the formula P cap equal to X over N. So let's look at the data. The P cap equal to 6 over 32, which is the number of data is 32. So Q equal to 1 minus P cap, which is 1 minus 6 over 32 equal to 26 over 32. So the alpha equal to 0.05 as 1 minus 0.95 equal to 0.05, and the z alpha over 2 by from the z square from the z data, the z table, equal to plus minus 1.96. So when we put into the formula, which is p cap plus minus z times square root of p cap times 1 minus p cap, which is q over n, so we got the answer is 0.3227 and 0.523. Let's go on to the next question, which is question number 3. For question number 3, find the 95% confidence intervals for standard deviation for weight of male respondent. So let's look at the data. The number of male respondent from my data is 16. So the degree of freedom, which is n minus 1, is 15. So the alpha is 0.05, and the standard deviation from my data is 21.303. So for the x square of alpha over 2 equal to 27.488, and x square 1 minus alpha over 2 equal to 6.262 from the table. So we're using chi-square table. So when we put into the formula, we get the answer of 15.737 and 32.971. So let's go on to question number 4. For question number 4, test the hypothesis that the average serum cholesterol is different from 215 milligram percentage at alpha equal to 0.05. The population standard deviation is 22. So let's look at what we need to find. We need to find first is the mean, which is x bar equal to 216.969, and the n is the number of data is 32. The standard deviation is given 22, so the alpha is 0.05, as this is two-tail condition, so it will be 0.05 over 2, which is 0.025. So the z-score is plus minus 1.96, and the average is given 215. So let's test the hypothesis using the formula, which is z equal to x bar minus mu over standard deviation over square root of n. When we put the formula, we get the z value is 0.5063. And when we draw the diagram, we will look at that the 0.5063 does not fall in the critical region, which is plus minus 1.96. So we need to accept the null hypothesis. So as there is not enough evidence to support the claim that the average serum cholesterol is different from 215 milligram. So let's go on to question number 5. For question number 5, is there any significant difference on average serum cholesterol between male and female respondent at alpha equal to 0.02? Assume different variance. So let's look at what we need to find in the data. So the alpha is given 0.02. So this is two-tail condition. So alpha over 2 equal to 0.01. The number of data for male for my set of data is 16, and for female is also 16. The critical value from the T table is 0.01 at 15, as the degree of freedom is 15, is 2.602. So the X bar for male is 222.125. So the X mean for the female is 211.13. The standard deviation for male is 23.7511, and the standard deviation for female is 15.7405. The hypothesis given, the mu for male is equal to mu for female. However, the null hypothesis is the mu for male does not same as the mu for female. So when we put the value in, when we draw the diagram, we find the value of t equal to 1.448. And when we draw the diagram, 1.448 does not fall in the critical region. So we must not reject the null hypothesis as 1.448 fall in the non-critical region. There is not enough evidence to support the claim. There is significant difference on average serum cholesterol between male and female respondent. And last but not least, question number 6. Build a simple linear regression between x equal to serum cholesterol and y equal to systolic pressure. So, based on the question, x equal to serum cholesterol and y equals to systolic pressure. So we need to find the regression line equation. Regression line equation equal to y prime equal to a plus bx. So when we put all the data, the sum of x, sum of y, sum of xy, sum of x squared and n equal to 32, we put all the data in and we got the answer y prime equal to 84.0265 plus 0.227x. So that is the answer for question number 6. So I think that's all from me. Thank you.